Hey, 8th graders, we are moving on. So just to recap, last Wednesday, we were working with writing linear equations given 2 points. Okay, so you guys did your practice with that. Today we are moving on to word problems. This is actually split into 2 sessions, 2 days. So we're just going to go over the first one for you. It's not as scary as you guys all act like it is. It's not that bad. So we're going to break it down. This one says the graph shown models the scenario below. So this graph is going to show this scenario. At Kayak Jacks, people pay a fee to rent a kayak, and then they pay a certain amount per hour. So we are going to define our variable. So I picture this like a y and an x-axis. If we were to label these, what would we label it? Like, what is the independent, what is the dependent? So in this particular case, our x, what is happening here, this is time. So how long did people rent the kayak? So this is time, and we are talking about time in hours. Then our dependent is our y, and this is going to be our cost, or the amount paid. And this, of course, is going to be in dollars. So you guys have done some practice. We can write an equation from this just by looking at the graph. You need to be careful because this goes up by, it doesn't go up by ones, 1, 2, 3, 4. Okay, it goes up, looks like, by 30-minute increments. So this would be 1, this would be 2, this would be 3, that would be 4. So we need to be careful of that. And then this looks like it goes up by tens, 10, 20, 30, 40, 50. So that's a little bit easier. So they say, let's find the slope and the y-intercept. Be careful. And the reason why they say be careful is because these do not go up nicely. And so let's take that into consideration. I'm going to find a couple of nice intersections here. So for example, I would find this, that. So if I go up, I'm actually going up 10. And if I go to the right, I'm really only going over 1. So your slope is 10 over 1, which is really just 10. Okay, so interpret the meaning of the slope. Well, the slope is what happens every hour. So why does it go up $10 every hour? Well, this is what they're paying per hour. So what we're going to interpret from this is the fact that it costs $10 per hour to rent a kayak. Okay, the y-intercept right here, 10, 20, 30. The y-intercept is 30. What does that mean? It means that the fee that they are talking about is $30. Okay, so the linear equation that models the scenario, you guys probably could have written the equation without much having to do here, but we need to tie it to our word problem. So $10 an hour plus the $30 fee. And this is pretty free, when you go someplace to rent something or to do something, you usually pay a fee and then pay an hourly rate. And so these types of situations are actually very common. So again, slope-intercept form, rate of change, which is our slope, fee, starting value right here. And most of the time, you're only going to be working in this positive first quadrant of the graph. Okay, now that we have this equation, we can use it to solve the problems below. How much would it cost to rent a kayak for 5 hours? Does your answer agree with the graph? So one other thing that I like to do is when I write this out, this is 10x plus 30. X is the number of hours, and y is the cost. Just kind of like how we defined, above, but sometimes it's nice to have it on the equation because then when you do the equation, you can see what that is. So 5 hours, you're going to put it in for x. So y equals 10 times 5 plus 30. Y equals 50 plus 30, which is 80. So it's $80. Well, let's look at our graph. If we went to 5, it would be right here. Does it go with 80? 50, 60, 70, 80. Oh, you guys can't even see that. 50, 60, 70, 80. So yes, it does work. Does it agree with the graph? Yes. Okay, so now this one's kind of working it backwards. It says Sally paid $150. How long did she use a kayak? So instead of putting it in for X, you're going to put it in for Y, because that's the total cost. You are questioning how long, how many hours. So then we're going to get X by itself. So I move the 30 over to the other side. 150 minus 130 is 120. Divide both sides by 10. 120 divided by 10, it's like taking that 0 off. We get 12. So how many, what does the 12 stand for? It's a number of hours. So 12 hours would be your answer. Okay, so next one, we got a few more to practice. These are kind of, they look like they're a lot, but they're only really 4 problems. So Morgan worked a summer job. She saved her money during the summer. The school year is starting and she plans on spending the same amount each month. So you can happen, what's happened? She's starting with a bunch of money and she's spending. So X stands for what is happening down here. This is the time, the number of months. And Y, because this is over time, what's happening? It stands for the money. Okay, so let's look here. Pay attention again. So this goes 1, 2, 3, 4, 5. It goes by 5s. This goes by, it looks like 200, 400, 600, 800. It goes by 200s. So let's find our nice intersections. Well, you got one right here. Looks like right here. So it's decreasing, so it's going down. It went down 200, 400, 600. So it went down 600 negative, and then it went over 2, it looks like. So if you simplify that, we have a slope of negative 300. And that means that she spends $300 each month. Okay, it's going to go down. So spending is that negative. And the y-intercept is 2,000. It's all the way up there. And this means that she saved $2,000 during the summer. Okay. So then our equation. It's going to be in slope-intercept form. So our slope, remember, is at negative 300. X plus 2,000. Okay. Another situation. To start his lawn mowing business, James had to first buy a riding lawnmower. Once he bought it, he started earning a consistent amount of money each week. So this one actually has you start in the negative. And why is that? The reason is because he had to spend money to make money. You've probably maybe heard some business people say that. Okay, so let's figure out what we would go by here. 200, 400, 600, 800, 1,000. So this looks like it was negative 1,200. The lawnmower was negative 1,200. So that would be our y-intercept. Oops, sorry, I shouldn't have wrote that there. It would be right here. Our two variables are x. Looks like it's weeks, because this is the number of weeks. A lot of times your x will be in time. And then our y is going to be shown as profit. That's why this is negative, because he started with no money. He started negative. The slope. Let's find some nice points. We got one right here, here. So it looks like I'm going up 200, 400, and over 1. So it looks like I'm going positive 400 over 1. So that means the slope is 400. this means that he earns $400 per week. And then the intercept was the cost of the lawnmower. So you could figure out how many weeks does he have to work before he starts covering the cost of that lawnmower. So your slope is that positive 400. We are increasing every week, but you've got to take away the $1,200 because that was the initial cost of the lawnmower. Awesome. Okay. The value of Sarah's car is decreasing by a consistent amount. So the consistent and constant, same type of thing. The value of her car can be modeled by this. So they gave you the equation. Now this is the same equation. I could technically write it like this. But a lot of times they'll write it with the 18,000 first because you're subtracting, okay? So what is the y-intercept in this meaning? Well, the y-intercept is $18,000. And what does it mean? It means the value of Sarah's car at this beginning. And maybe I should say starting value. What is the slope and its meaning? The slope is a negative 1,500. And this means it's the amount the car decreases in value. The car decreases per year. Okay, so how long will it take for the value to be 7,500? Okay, well that means the total, what it's worth. So I would put that 7,500 right here, and I'm going to just use that 18,000 minus 1,500x. What we don't know is how long. Okay, so the first thing that I would do is I would move that 18,000 to the other side by subtracting.